Find the length of the arc on the parametrized curve, RT equals 2 square root of 2 over 3, t to the 3 halves, comma, 1/2 t squared, comma, t plus 3, as t goes from 0 to 2. First, we write down our definition. So we'll have length is given by, you can either integrate over your curve against the parameter for arc length, but since we have a parametrized curve as is, we're just going to use integral from 0 to 2. Okay, we're going to take r, take its derivative, take the length of the derivative. Then we integrate that against dt. Now, take the derivative, what do we get? Well, square root of 2, t to the 1/2, comma t, comma 1. I take the length, that gives me 2t plus t squared plus 1, all square root. Okay, the inside factors as t plus 1 squared, so we get t plus 1. Okay, we don't have to worry about the sign for the square root since we're going to have, okay, t is 0, t is 2. This is always a positive number. So that's going to be what we integrate against. So we have our length is integral 0 to 2, t plus 1 dt. I have an antiderivative, 1/2 t squared plus t. Put in 2 and 0, take the difference, and we get 4 for our arc length. Where's our formula come from? Let's take a parametrized curve in 3 space, chop it up into a lot of little bits. Then the endpoints, we're going to just connect with straight line segments. So this is going to give us an approximation of our curve, and the length of this approximation will approximate the length of our curve. Now, if I take one of these little segments, call its length L sub I, then if I put in the rectangular box, we'll label the box with dimensions delta xi, delta yi, delta zi. Li is then going to be given by the square root of, take each of those items, square them, and then sum. We want to introduce our parameter in here, so that's delta ti. So what I'll do is, I'll divide delta xi by delta ti. Okay, it's going to get squared. So to correct, I have to multiply by a delta ti squared. Okay, we do that for each term, and then I can factor it out. And then to get it out of the square root, it comes out as delta ti. So that's all this is. Okay, so that's L sub I. I want to sum over all the L sub i's, and then we're going to take delta ti going down to 0. So that limit's going to give us our length. Now, this is our limit process for integration. So what happens? We're going to have the summation sign goes to our integral sign over our range. So that range is going to be over the values of t that we're interested in, our parameter. Okay, our delta ti is going to go to dt. And then on the inside, each of these delta x over delta t, delta y over delta t, delta z over delta t, they're going to go to the derivatives of x, y, and z with respect to t. So we're going to get this term here inside the square root. And note that that's just the definition of r prime, take its length.